Welcome back to the Clover X and on the episode number 2, chapter 2 of the page of SCC curriculum. In chapter 1, we got our bearings, navigating the file system, understanding permissions, writing and running our first script. But that script just did one thing, it had no brain. It ran the same way every single time, no matter what. Chapter 2 is where scripts get intelligent. We are adding variables, memory, user input, the ability to react, conditionals, decision making, and loops, repetitions. By the end of this episode, your scripts will behave differently depending on what they are given. That's the difference between a command list and an actual program. Okay. What is a variable? A variable is a named container for data. You give it a name, assign value, and then use that value anywhere in your script. Instead of hard coding the same string in 10 places, you store it once uh, and refer it everywhere. Okay, so let's create name.sh and write first variable. Touch. No. Okay, write this. Write this. Notice three things. No space around the equal sign. The value is in quotes, and to read the value back, we put a dollar sign in the front of the name. The three rules to burn into memory. Rule one, convention is uppercase. My name, not small letter my name. Rule two, no space around name and then your name equal to and the variable name or not name equal to something. No spaces around the name equal to sign. Rule 3. Read with dollar. Echo dollar my name or echo double underscore sorry double quotes with dollar my name. The no space rule is the one that bites everyone early. Name equals space quote clover hyphen hyphen. Okay, so name equals Bash will try to run name as a command and fail. No space here. Let me to show you. Okay, so it gave a error on line number 3, my name. Command not found. Okay, so quoting matters. Now we will go to the quoting and that matters now. Double quotes allow variable expansion. The double sign inside gets replaced with the value. Single quotes treat everything literally. The dollar sign is just a dollar sign. You will use, as you can see, that output is for double quotes is print hello Clover, while the output for the single quotes is hello and dollar my name because the single quotes take the dollar sign literally as a dollar, not as a variable. You will use double quotes almost always. Single quotes are for when you genuinely want The literal dollar sign, like writing a shell script that generates another shell script. One more thing, uh, curly braces around variable name. This is the safe way to expand a variable when it's right next to another text because Bash needs to know where the variable name ends. Okay, so here is something powerful. You can capture the output of command into a variable. You wrap the command in a dollar sign and parenthesis. This is called command substitution. We will use this constantly, capturing the output of call, grep, awk, date, and filling it into our logic. It's one of the most useful things in Bash. Bash also has a set of special variables that are always available. You don't declare this, they just exist. We will use $1 and $hash when we get to exercise 2 and dollar question mark gets its own section soon. Just know this exists. You will see them everywhere. A script that can talk to the user is limited. The read command pauses execution and waits for the user to type something, then stores what they typed into variable. That two-line echo then read pattern works, but there is a cleaner way. The -p flag lets you put the prompt message right in the read command itself. Same result, one line less. This is the pattern you will see in almost every script that asks for input. One more read flag worth knowing right now. -s for silent. When you use -s, the characters the user types don't appear on the screen. This is how you ask for password. Okay, you can also read multiple variables in a single read code. Each word the user types maps to the next variable in the order. Uh, you can see that. Okay. Why conditionals? Okay. A script that always does the same thing regardless of input isn't very useful. Conditionals let the script ask a question and take different paths based on the answer. This is the core of intelligence in any program. Okay, let me break this down piece by piece because the syntax of bash conditionals is very specific and small mistake cause silent failure. The spaces inside the square brackets are not optional, they are mandatory. Dollar hyphen username with no spaces will throw an error. This catches everyone at least once. Always quote your variables inside conditions, double quotes and around variable. If user hyphen name is empty and you don't quote it, bash sees as equal something like like equal stages, two tokens instead of three and crashes. What if we need more than two paths? We add elif block between if and else. Elif is a bash else if. Hmm. What if we need more? The square brackets support a whole range of test conditions. Let me walk through the one you will use constantly. Don't memorize all of these right now. Know that they exist and keep this list handy. The file tests hyphen f and hyphen d. You will use in almost every non-trivial script to check if something exists before acting on it. Let's use hyphen f in a real context, a script that checks whether a file exists before trying to read it. A classic defensive pattern. As you can see, it checks. I have given the hello.sh and it's checked if the sh file hello.sh file is exist or not. At the same time, I also checked for the file name host.sh, but host.sh is not created in my directory, so it gives does not exist. You can combine multiple conditions with and ampersand and o double pipe. This work inside the double square bracket syntax. Notice I switch double square brackets here. Double brackets are a bash extension. They are safer and support double and double and directly double power. When you are combining conditions, use double brackets. Every command in every command in Linux, every single one leaves behind a number when it finishes. That number is the exit code. Zero means success. Anything other than zero means something went wrong. Okay, so as you can see, I have done ls hyphen home. This works and prints zero. As you can see, ls home and I have echoed dollar question. So dollar question mark always holds the exit code of the last command. Run it immediately after the command you want to check. If you run anything else first, the value is overwritten. So ls is I will go and check and then nano no exist file. And if I put echo, okay, so there is a exit code of 2 means there is something error. 2 means no such file exists. Okay. In a script, you can set the exit code yourself with the exit 0 signals success, exit 1 or any non-zero number signals failure. Sorry. Okay. This pattern checks something. This pattern checks something exists if it's wrong. Okay, so there is a exit code 1. So there is a exit code 1 is called a guard close. Bail out early with a clear error message rather than letting the script continue and produce cryptic failure 10 lines later. So we will move on to the exercise 2. Exercise 2, write age verifier.sh 3 requirement and the hint is implement requirement 3 before requirement 2. Pause here and build it yourself. The hint about requirement 3 first is important. Think about why before you look at the solution. The reason we check for empty input first is guard close logic. If age is empty and we go straight to comparing it numerically, base throws an error. You can't compare an empty string as a number. So we validate the input before we use it. Always test all paths for this script. There are three distinct cases. Three test cases, three different outputs. All three branches verified. This is how you test script. Don't just run the happy path. Loops are how we tell a script to repeat something. Instead of writing the same command 100 times, we write it once inside a loop and tell the loop how many times to run it or what list of things to run it against. Use a for loop when you know the number of iterations ahead of time or when you are iterating over a known list of items. Basic syntax for where in list 2 commands using $where The curl brace range syntax 1 dot 5 generates the numbers 1 to 3, 4, 1, 2, 3, 4, and 5. The variable I takes each value in turn, and inside the loop body, we use $I. The book mentions the range is inclusive on the left but exclusive on the right. Let me verify that for the terminal. Always test your assumption. Actually, curly braces 1 dot 5 curly braces gives you 1, 2, 3, 4, 5. Both ends are inclusive in bash brace expansion. Always verify at the terminal rather than taking any reference at face value, including books. For loops, don't have to iterate over numbers. You can loop over a list of words, IPs, usernames, anything. In an offensive context, imagine that list is a set of IPs from the subnet. Your loop pings each one, checks the response, and logs the result. You will build exactly that kind of script in part 2. You can also loop over files using a globe pattern, the asterisk, which is incredibly useful. For file in if you are coded in C, Java or JavaScript, you might prefer the C style for loop. It uses double parentheses and gives you explicit init conditions and increment. Both styles produce the same result. Use whichever feels more natural. The brace range is more bash idiomatic. The C style is more familiar if you come from other languages. The difference between for and while is simple. Use for when you use for when you number of iteration. You are looping over a fixed list. Use while when you don't know. You want the loop to keep running until a condition changes. Let's build the countdown example from the book. A few things to point out here. The double parentheses count are how you do arithmetic in base. The C style decrement operator, the C style decrement operator works inside them. Without the double parentheses, count would just be a string. Let's make the arithmetic rule explicit because it trips people up. Outside of double parentheses, base treats number as string 1 plus 1 without parentheses doesn't give you 2. It gives you a string that says 1 plus 1. Always use dollar and 2 parentheses for path. A powerful pattern is the infinite while loop. While true combined with a break statement to exist means break statement to exit when you decide to. This is how menu-driven scripts work. The break statement immediately exits the loop. The script continues with whatever comes after the done keyword. There is also continue, which skips the rest of the current iteration and jumps back to the top of the loop. Okay, so exercise 3, factory.sh. This one brings together chapter 1 commands and chapter 2 loops. Pause, try it yourself. The key challenge is constructing the file name dynamically inside the loop using the loop variable. Key detail here is using $I inside the file name string. The curly braces make sure base knows where the variable name ends and the .txt begins. 10 files, 10 messages, all created by a loop. That's only 4 lines long. That is the power of loops. You wrote the creation logic once, the loop did the repetition. Quick thought experiment. What happens if you factory.sh a second time? Try it. I will try it myself too. Okay, so you can see there is an error called mkdir cannot create directory cache logs. The file exists. It fails because test logs already exist. This is a real scripting concern. Scripts that crash on the second run are fragile. The fix is to check if the directory exists before creating it. Explanation mark before hyphen D means not. So this reads, if this directory does not exist, then create it. This pattern makes your script safe to run multiple times. Everything I have covered in the chapter 2, I have listed on the screen. So for the chapter 3, text processing and functions, we are going to learn how to organize scripts into reusable functions, work with arrays, and then unlock the holy trinity of text processing, grep, sed, and awk. In Offense Security, most of what you are doing is processing text, command output log files, config files. These three tools will change how you think and think about data. Okay, so do both exercise, the edge verifier and the factory script. Then try extending them. Make factory.sh accept the number of log files as a command line. As a command line argument using $1. Put your solution in the comments. See you in chapter 3.